Alright, good morning. My name is Jeremiah Flores. Today I'll be demonstrating how I'll be implementing and testing three different function calling conventions in assembly. The three different functions being fast call, CallStackLabredo, and STD call. This project is for the CallStackLab examples in ITT 210. I'll show you how each of these conventions work and how they affect the program's behavior. So of course we'll start off by showing the code. I'm already in debug mode, so let me exit. Here we'll be seeing the source ASM, the full code itself. You can see where the demo fast call starts, and then the array sum, and then the array sum CallStackLabredo, and finally the STD call. This program itself has already breakpoints preset in them, so unless you're writing the new code entirely, you do not have to worry about that for this. So we'll start debugging. You could of course start off by cleaning the solution. That will make it ready for it to be debugged. So start debugging. You'll see the register values themselves up here. Your program will begin basically executing at this point, and it will stop at the first breakpoint, as you can see right here. Once the program stops at the breakpoint, you'll see the values of the registers itself. This will open the window, of course, once you debug, and you'll see EAX, EBX, ECX, and etc. For each breakpoint, you'll expect the values of the registers, especially EAX, since that's where you'll show the result of your arithmetic will be stored right here. So you're going to go ahead and step through the program, step through the breakpoint. You can either press F10 or step over to move to the next instruction. If you want to step inside a function, observe how the registers change after each of these instructions that I will be providing. So as you can see, AX, the value for a change, ECX change, and this value changes as well. So of course, we're running the first test for the demo fast call. You'll be viewing the values, and the arithmetic for this is EAX equals EAX plus EBX minus ECX plus EDX. So after the call, you verify the results of EAX. So we'll go ahead and continue on. You can see the values, how they change. So ECX 12, you could see that up here. Move EDX 8. You can see the change here. And you do that all the way through until you get to the array sum. And then at that point, you'll be testing the other files in themselves, the array sum, the CallStackLabredo, and the STD call. I'll go ahead and continue on. As you can see, the program runs as expected with the correct results being stored in EAX. This will entirely demonstrate how the three calling conventions handle function calls and parameter passing differently through each of these calls. As you can see with the array sum, the sum is now correctly stored in EAX. Now we'll test the CallStackLabredo. We can see the result of EAX is correct after the call to CallStackLabredo. And once we get to the STD call convention, where the called function clears up the stack, we can confirm that the result is again correct in EAX. As you can see there. The program behaves as expected, and the results are consistent with the operations we've defined. The key takeaway here is that each calling convention handles parameters and stack management differently, but the outcome remains accurate and the same. After completing all the tests, you can verify the calculations as I stated. Everything works as expected. The results match the operations we've defined. And that's the end of the project in itself. Thank you for watching.